This is video 3 of looking at the standard normal distribution. And so now that we've practiced a lot of things with the table, you may be asking the question, why do we still need the z distribution? Because we don't need to look at the table and we can just put this into our calculator. Well, it turns out that if you have a situation where you have two populations, so right here it's describing it, two populations with different means and different standard deviations, and you want to compare them in some way, it turns out that it's going to be good to be able to turn them both into a z distribution. And then once you have them both as a z distribution, then you'll be able to compare them. So that's what we're going to do in the next example. But I just want to point out here, before we do that, before we wrap up, remember when we talked about the formula for the probability density function for a variable that's normally distributed is kind of this really complicated equation. So it was 1 over sigma times the square root of 2 pi times e to the negative 1/2 x minus mu divided by sigma squared. So this is for a general variable, continuous variable that is normally distributed. All right, but the z distribution, all right, the standard normal distribution, remember, has mu of 0 and sigma of 1. And so if we substitute that in, we get this more simplified equation, which is down here. So notice here on the top one, we have sigma, and sigma was 1, so that just becomes 1 over the square root of 2 pi, so you can see that here. And then up here we have e to the negative 1/2, so that part is still there. But then up here we have x minus mu, mu is 0, and then divided by sigma, which is 1, so x minus 0 divided by sigma, which is 1, is just x, so we just get x squared, and so that's what you see up here. So I just wanted you to see that, that if you have a z distribution, we can take this messy formula and reduce it so that it's a little more reasonable. Okay, so let's jump into the example. All right, so the example says Kelly scored 73% in history, where the class mean was 68% and the standard deviation was 10.2. In math, she scored 66%, so her actual percentage was less in math, where the class mean was 62% and the standard deviation was 6.8%. So notice that in both classes, she scored above the mean. In history, she scored 73, and the class mean was 68. Math, 66%, mean was 62. Standard deviations are different, though. And then the question asks, in what subject did she perform better compared with the rest of the class? All right, and we're going to assume that both subjects were normally distributed. So let's make a little table here just to kind of summarize this. So Kelly took 2 tests. She took a history test and she took a math test. And she scored 73 in history, and she scored 66 in math. All right, then we had the class mean. So the class mean in history was 68. In math, it was 62. And again, there's where we can see that she scored above the mean. And then we have the class standard deviation. So in history, it was 10.2, and in math, it was 6.8. So what we want to do is turn both of those into z-scores, and then we can compare them. All right, so in history, her z-score, according to the formula, is going to be her score, which is 73, minus the mean, which is 68, divided by 10.2, which turns out to be 0.490196, and so forth. So remember that appears then, that would appear on the z distribution, as of course this is 0, this is 1. So 0.49 would be, about halfway here, all right? So basically what that's saying is that she scored 0.490 above the mean. Okay, all right, so now let's take a look at her math score. So her math z-score is going to be her score, which is 66, minus the class mean, which was 62, divided by 6.8. And that turns out to be 0.5882 and so forth. All right, and so remember what this stands for. Let's do this in a different color. So 0.58, so something like this, a little bit above. Right, so she scored 0.5882 above the mean. All right, and then hopefully you can see from that that the subject that she did the best in was math then, because she scored more above the mean in a relative sense than she did in history.